curious and authoritative. In factories all over the world, millions of hours are lost every year to a single invisible force, gravity. Most operations accept this physical strain as an unchangeable cost of doing business. But at Idea Mechanics, we use the TRIZ playbook to prove that innovation isn't about working harder, it's about engineering the environment so the resistance disappears. To master these systematic blueprints for yourself, subscribe to the channel and join the Idea Mechanics team. And let us know in the comments which technology or innovation framework we should break down in our next session. Most facilities are currently stuck in a trial and error trap. They treat cluttered floors and vertical obstacles as fixed realities. This forces workers to navigate around machinery, climb stairs, and perform repetitive bending just to move materials from point A to point B. Every time an operator or a machine fights gravity to move an object, you are losing energy that could have been used for production. This structural waste directly impacts your cycle times and creates long-term safety risks for the workforce. Shifting away from brute force requires a new perspective. In TRIZ, this is Principle 12, Equipotentiality. Equipotentiality creates a state of uniform potential, leveling the physical playing field to neutralize a force field like gravity. By establishing this level plane, objects and people move horizontally with minimal effort. With no height change, you are no longer performing work against gravity. This approach moves us beyond reactive fixes. It allows us to modify the environment so that it works with natural forces instead of against them. On a macro scale, factories install elevated platforms and walkways. This structural change builds a new equipotential plane right over the cluttered machinery, allowing workers to navigate the entire facility on a straight horizontal trajectory without ever needing to change their vertical position. On a micro scale, we apply this same logic at individual workstations using conveyor belts and hydraulic lifts. These tools ensure that materials are always held at the optimal working height for the operator, regardless of the size or weight of the part. When the material moves at a constant potential energy level, you remove the need for bending and lifting. This stabilizes the workflow and protects operators from the musculoskeletal strain that leads to downtime. This principle reaches its peak efficiency when moving bulk materials like powders or granules over long distances, tasks that traditionally require intense manual labor. Instead of heavy lifting, pneumatic systems use a stream of air to propel materials through sealed pipelines. Inside, materials become suspended in the airstream. Floating the particles minimizes contact and friction. Air pressure does the work, effectively removing the gravitational load. The result is a hygienic, automated flow that uses fluid dynamics to replace the physical strain of traditional material handling. When these engineering solutions are integrated, the factory becomes a frictionless ecosystem. Every walkway and pneumatic tube works together to keep the facility in a state of continuous movement. The physics are simple. Every time a system is forced to fight gravity, it loses efficiency and increases the risk of injury. Real innovation happens when we stop trying to overpower gravity and start acting as architects who design it out of the process. A manufacturing system achieves its most stable and predictable output when it no longer has to expend energy fighting the laws of physics. Take a look at your own logistics or production lines. Where are your operations still struggling against the weight of gravity? Identify the bottlenecks where you can introduce an equipotential plane to smooth out the flow of your work today. Share your findings in the comments. Frictionless engineering is a repeatable discipline, and you can start applying it to your own challenges right now. We'll see you in the next one.